Hi! Welcome to the course MVVM in WPF Survival Guide from A to Z. I am Elias Fofanov, aka Engineer Spock from engineerspock.com, and I'll be leading you through the course. MVVM stands for Model View View Model. MVVM is a well-known architectural pattern, which is the main way of building enterprise WPF applications. This course will be helpful for students who is acquainted with WPF framework, but do not have any experience with building real-world WPF applications. I'm sure that this course will be beneficial for students who have experience with building MVVM-based WPF applications in the case they want to understand how MVVM frameworks are organized under the hood. This comprehensive course covers the vast majority of topics. In the introduction module, we're going to consider the main ideas of MVVM, why we use MVVM and why it is so popular in the XAML-based world. The other modules cover the following topics: how to connect views and view models, including view-first and view-model-first approaches, how to support the design time data, how to configure and use an IOC container inside a WPF application. We will use the Castle Windsor IOC container. How to organize the communication channel between views and view models. We will look at commands, attached and blend behaviors, and how to use a static message bus for communication between different components. How to organize navigation. We will look at a hierarchical UI composition. We will look at how to open dialogues, including modal dialogues. The important topic here is how to navigate to parameterized view models if you want to pass parameters into their constructors. What are models in essence and how to implement validation on domain objects. In the end, we will take a brief look at MVVM toolkits. We will look at caliburn.micro more closely. Actually, there will be an additional topic. I'm talking about unit testing. In the appendix, we will take a brief look at how to write a couple of unit tests for view models. I felt that the MVVM course will not be complete without any demos of unit testing. In this introductory module, we're going to talk about theoretical things. Don't expect from the introductory much practice. If you want to get right into practice, you can skip the first module and start the second. The main goal of this module is to give you the fundamentals, to briefly explain what stays behind the MVVM pattern. The other goal is to broaden your horizons and increase erudition. So we will talk about maintainability, testability, separation of concerns, and single responsibility principle. Then we will talk about the MVVM in essence, which problems this pattern is capable of addressing. Right after that, we will consider the structure of the MVVM pattern. We will take a look at its building blocks and responsibilities of that blocks. As a separate topic, we will briefly talk about services in MVVM-based applications. Then we will take a look at the application written without MVVM, where we cram all the stuff inside the code behind. On that example, we will quickly address all the problems connected with the monolithic approach. Then we will swallow a bitter pill because there are no any approaches without flaws or downsides. The MVVM pattern implementation within the WPF platform also has some downsides. Fine, let's move to the next lecture, where we will be talking about the problem of applications maintaining. If you had any experience with the maintaining of a big application in a long term, you would have known how much pain developers feel throughout the entire process. The code base always tends to become a mess, a big ball of mud, which sooner or later makes developers frustrated and in the end just buries the project. History knows thousands of software projects which started successfully and eventually died because they came out of control. They became unmaintainable, too much so-called technical debt accumulated over time. That's why maintainability is so important. Not only maintainability determines the healthiness of a software project. Testability is not less important than maintainability. Testability, as the word implies, means the ability of an application to be tested. In this context, I am talking about automatic testing, of course about unit testing in the first place. In my opinion, the maintainability depends on the testability. By stating this, I really mean that the testability is one of the primary goals of designing the application's architecture. If an application cannot be thoroughly tested, then it almost for sure cannot be easily maintained in a long term. The next important notion I want to address in the context of applying MVVM is the separation of concerns. Separation of concerns is a well-known designing principle. Following this principle enables us to break an application into independent components, independent as much as possible. This principle underlies the MVVM pattern. The MVVM pattern applies the single responsibility principle to achieve the separation of concerns. Thus, you can say that MVVM helps you to make your application well structured. To sum up, I'll say that you have to apply some kind of architectural pattern on the UI boundary of an application in case you want your application to stay alive in a long run. There's also the MVPVM pattern can be used with WPF, but this pattern is out of the scope of this course. Great! Let's talk a little bit about why MVVM pattern is so popular in WPF applications. MVVM is the most popular so-called presentational pattern applied on the UI boundary in WPF. The history of presentational patterns takes place from the introduction of MVC pattern in 1979. MVC stands for Model View Controller. Another presentational pattern named MVP, which stands for Model View Presenter, was introduced in the 90s. Both patterns try to achieve the high maintainability and testability of an application. They just do it in a different manner. One of MVC pattern modifications is now widely used in the ASP.NET framework. The MVP pattern is widely used in Windows Forms. MVC and MVP patterns are out of the scope of this course, but I wanted to mention them in order to broaden your horizons. Let's get back to the MVVM pattern. It was introduced in the 80s for the first time. Omitting some irrelevant details, I would say that the modern version of MVVM was born in 2005 and it was specifically tailored for WPF. Why particular patterns become a standard for implementing UI boundary of applications? It highly depends on a language and a framework. For example, MVVM can be naturally and easily adopted for WPF because of its extremely powerful data binding subsystem. In addition, WPF provides commands, dependency properties and triggers, what also helps to implement MVVM. MVVM allows you to achieve high testability and maintainability. But how exactly? MVVM separates the presentation part and business logic. By presentation part, I mean all UI-specific code which sits in the corresponding generated g.i.cs files and all code which arise in the code behind. When business logic is not intertangled with the UI-specific code, it allows you to easily meet new requirements and changes. It's much easier to introduce new features when you know where to introduce them exactly. It also makes bugs isolation much simpler, since you have a layered architecture with well-defined responsibilities of components. Testing the UI itself is difficult and brittle. The separation of business logic naturally leads to more testable design. If you want to test UI-related code, you can test view models, which is a part of the presentational logic in MVVM. Unfortunately, I should note that the separation of business logic by applying the MVVM pattern is a necessary but not sufficient condition to make an application easily testable. The only thing I'm sure in is that without separating of the business logic, the testable design cannot be achieved at all. Also, I want to notice that MVVM enables easier code reuse since components are separated by their responsibilities. Pure MVVM, which is applied properly, allows reusing models as well as views and view models. The most beneficial point here is the reusability of models, of course. Another advantage is that the codebase is easier to understand since it's well organized. The last but not least advantage I want to mention is that the MVVM pattern does not depend on a platform. You can rely on the MVVM on Silverlight, WPF and UWP platforms. In short, you can implement the MVVM on any XAML-based platform. Okay, Let's look at the building blocks of the MVVM pattern more closely. As we have already said, MVVM stands for Model, View, View Model. It means that the UI boundary of an application consists of three main parts: Model, View, and View Model. Let's consider the responsibilities of these parts one by one. Let's take a look at views. A view is a presentation of some data that should be displayed on a screen. A view can be defined in terms of a window, page, or a user control. Views in MVVM should not contain any business logic. They should stay simple as much as they can. So, in most cases, views do not contain any code behind, except the required part with the constructor and a call to the initialize component method. It's hard to precisely define the notion of purity of MVVM implementation. I can say for sure that as less code your views contain, the purer your MVVM implementation is. Of course, there are always trade-offs arise during the development process. Sometimes it's much simpler to add some view-related code into the code behind, rather than implement tons of abstractions for the sake of moving 3 lines of code from the view to the view model. But the general rule of thumb is that your views should not contain any logic inside code behind files. Always think twice before deciding to implement something inside the code behind. Views are hard to test by their nature. No one wants any windows to pop up during unit test sessions. That's why we strive to keep all the business logic outside of views. Actually, views can be tested, and sometimes they should be tested. The approach to views testing is different. We don't want to write unit tests to test views. It's almost impossible. Instead, we write the so-called integrational tests. There are 2 main approaches for writing integrational tests for views. The first one is record and replay approach. In short, you launch an application, click on UI elements and set some assertions using a specialized tool. Visual Studio supports this scenario. The second one is hand-rolled integration tests. They look like unit tests, but they are not. Often, you will rely on some framework such as Test Stack Wide, which supports programmatical interaction with UI controls. Remember, the responsibility of a view is to present some data for a user. Okay, let's move to a view model. View model is a mediator between view and model. It is like the glue. It communicates with the view through the data binding mechanism. Data binding is the most important WPF component, which makes MVVM so simple and powerful. View models do not contain any displaying related things. For example, there are no any UI elements, buttons, text blocks. The responsibility of a view model is to expose some data for displaying it by a view. So the view model notifies the view about changes via the iNotify property changed interface, and the view fetches corresponding data and then displays it. Sometimes view models can perform a preliminary preparation of the data. For example, they can preformat a string. Though it depends on a certain case, because data bindings which reside in views have converters and string format option at its disposal. Often, this kind of decisions is a matter of taste, but try to not expose in view models any UI-related things like colors or brushes. View models can contain some business logic. It is not strongly deprecated. You always have to decide by your own or your team if a certain part of the business logic should stay in a view model or move to a model. It also depends on a certain case. Take into account such factors as reusability, testability, and the current state of a view model. View models should not become too fat anyway. If you see that a view model becomes fat, then you should refactor it out before it's too late. View model communicates with models. It calls models methods in order to execute some business logic which mostly reside in models. Often, say, a user clicks on a button on a view dispatches a corresponding command, a view model handles this command and calls an appropriate method of a model. A model performs some business logic, and then a view model fetches some updated data from a model. Then a view model notifies a view, and a view retrieves that data from a view model and then displays it on the screen. Sometimes a view model can take a responsibility for calling to external services directly, though this is not always the case. A view model may be responsible for navigation between views, in the case of a view model first approach. You'll learn what it is in the next module. In this case, a view model is also responsible for triggering dialogues, what can be considered as a part of the navigation. Properly designed view models are testable. You can easily unit test its minimal business logic and interactions with models. Thus, view models' dependencies have to be abstracted away in order to make view models testable. We will look at this problem later in this course. And the last thing is that a view model instance becomes a data context for a view. This allows us to set data bindings between a view and a view model. A view model exposes operations which are commands in essence. Commands are objects which implement the iCommand interface. We will look at how to implement this part of MVVM later in this course. Okay, let's get to models. By the notion of a model can be implied different forms of objects. Models can be expressed in the form of plain CLR objects, so-called POCOs, in the form of domain models fulfilled by complex business logic, or in the form of special wrappers around POCOs. Models, of course, expose some data or state that can be displayed on the view. This data can also be potentially changed by a user. This data often is retrieved from some kind of persistent storage. A model may contain some business logic that can be expressed in the form of computed properties, validation rules inside methods of a model, custom logic inside updating methods, and so on. A model may implement iNotify property changed interface as well as may not. It depends on the form of MVVM. We will touch the problem of implementing iNotify property changed and synchronizing data between model and view model later in this course. A model can implement validation by implementing the iNotify data error info interface. There are other options of implementing validation, but the preferable way is to implement the iNotify data error info. Great! Let's talk a little bit about the services in MVVM. There's always a hidden part of MVVM: services. I can't say that services is a layer. It is more of a cross-cutting concern. Services imply navigation, data access, access to external services, caching, communication between views, and progress dialog support. These are the most important and commonly used services throughout a WPF application, which relies on the MVVM pattern. Services need to be decoupled from MVVM parts, since they have their own concerns which can be changed over time. Changes in services should not touch either models or view models. So, if a data access mechanism changes, say you should change it from the access to the local database to the data access through clouds, models and view models should stay unchanged. Thus, services almost always implement an interface. The dependent modules like models and view models often require to inject them via constructors. This makes the concrete service implementations abstracted away, what allows mocking out the dependencies in unit tests. So, view models and models become testable as a result. We will take a look at implementations of certain services in this course later. Often, services are injected by using an IOC container. IOC stands for Inversion of Control, which is one of the primary principles of object-oriented design. IOC containers are special frameworks which are used for automatic dependencies resolving. We will take a look at one of the IOC containers in this course. Okay, let's get acquainted with our educational application, which we will use for demos throughout this course. During our survey of the MVVM pattern, we will be building a simple application. Let's have a look at the application. I've prepared a separate solution where this application is already written with a monolithic design. This application is about managing a list of students. In short, the application should display a list of students. It should be able to add new students to that list, remove them, edit the existing ones, and submit changes to the data source. Let's look at the application via the codebase. Here is the student class, which represents the main entity with which we will be working throughout the course. It exposes ID, first name, last name, age, and email address properties. You also can see XML-related attributes. This class is marked with XML attributes because we will store students in the XML file. So we need to mark this class and its properties with the appropriate attributes in order to be able to serialize objects to XML and deserialize them from XML. Let's look at students.repo.xml. Students by default will be stored in the students.repo.xml file. We already have 7 students here. Let's have a brief look at how data access is implemented. Let's look at idataprovider.cs. I declared a generic interface named idataprovider_t, implementers of which should provide the access to a data storage. This interface declares the ability to retrieve entities from the data source by their ID, to change entities, add and remove them, retrieve all the entities and submit all the changes. Submitting the changes means that all the changes will be pushed to the data source. I should say that you will not find such a trivial approach to the building of a data access layer in the real world. I created such a broad and generic interface just for the sake of simplicity, since we're not going to dig the topic of data access very deep. It's a topic for a separate video course. This is just not feasible to explain all the peculiarities connected with the data access. Okay, let's look at the implementer of this interface. Let's look at students.xmlprovider.cs. This provider supports the ability to store students in the XML file by using the xDocument class internally. It receives a path to an XML file in the constructor. For serializing and deserializing students, it uses extension methods for the xElement class, which reside in the XML serializing extensions class. You can download sources and look at the implementation by yourself. Now let's have a look at the user interface. Let's go to main-window.xaml. Right now we're in the main-window.xaml file. It has a simple layout. It displays a list box, 4 buttons to manage that list, and a separate button for exiting from the application. Main window will open an additional window in case of editing a selected student. It will open the Add Edit Student window. Let's look at Add Edit Student window.xaml. This window has 4 text boxes for editing the information about a student. It also has 2 buttons. OK, which accepts the changes, and Cancel, which declines any changes. That's all for the acquaintance with the application. Let's have a closer look at how this application is implemented right now and what are the downsides of the monolithic design. As I've already said in the previous lecture, this application's architecture is monolithic. Let's have a look at the solution structure at first. We have 3 projects: Data Access, Modules, where the student class resides, and the Students Manager, which is the executable application itself. Let's have a look at the code behind of the main window. In this code behind, we see that all the things are implemented here. We have some logic connected with the UI. The list has selected items is defined here. All the handlers of the window lifecycle events will be also defined here. I call from the onInitialize handler the reloadStudents method. ReloadStudents method is a good example of mixing the concepts. It clears the list box on the UI, creates the data provider, then fetches all the students and manually adds them to the list box. All the button click handlers are also here. They also work with the UI and data access simultaneously. I'll say what will happen further. New requirements will arrive and the code base will grow. Since we put all the things into one place, this place will become a big ball of mud. Eventually, code behind files of Windows with tons of information will contain several thousands of lines. You'll find yourself scrolling up and down those code behind files in order to find a piece of code in which you are interested in. After some time, it won't help, because you won't be able to separate all the different concepts and keep the important parts in your head. That will just be impossible. Unfortunately, you will not be able to refactor out all that code, since it will crash all your application. No one will be capable of doing such a refactoring, because no one will understand how the code works. Extracting classes will not help much, since they all be crammed into code behinds in the end. If you decide to move to some kind of presentational pattern, you will need to almost completely rewrite your application. Notice that all the code here is not reusable, no matter what it is related to, either to UI logic or business logic. To sum up, we can say that such an approach will lead to, first, unmanageable state of data which should be displayed on the UI, poor reusability, code which is impossible to understand, and code which can be extracted to separate libraries easily. Okay, let's get to the next lecture. Any patterns have some cost of their implementation. Nothing comes for free. There are some unfortunate things related to MVVM and WPF. Let's look at the downsides. First, WPF does not provide any support of the MVVM pattern out of the box. A couple of years ago, people thought that Microsoft will eventually add some support of MVVM. That hasn't happened yet. Not so long ago, WPF team said that there are still no any plans to introduce some kind of support of the MVVM pattern. Second, the implementation of the MVVM pattern is not trivial. If we talk about relatively big applications, then I have to admit that it requires to understand and apply complicated techniques to implement many additional design patterns in order to go ahead with the MVVM for a long time. That's why there are plenty of MVVM frameworks. And if you want to pick one, then you have to grasp the difference between them by your own. Third, learning curve might be long. Of course, it depends on the experience of a certain developer, but generally speaking, MVVM is a very supple pattern, which comprised of many patterns which are specific for the MVVM design pattern itself. So it might take a decent amount of time in order to understand the MVVM pattern and all related peculiarities in depth. As a side note, I want to mention that you can make a mess applying the MVVM pattern as well as applying the monolithic approach. In the long term, of course, MVVM advantages outweigh the disadvantages. There is no meaning to rely on the beginners cram all this stuff into the code behind approach. Okay, let's get to the conclusion. Congratulations, you've finished the introductory model. That was a great brief survey throughout the little world of MVVM pattern within the WPF platform. In this module, we discussed the problems of maintainability. We found out that poorly designed applications will eventually die, choking in the mud of unmaintainable code base. We mentioned that the testability is almost a prerequisite for a high maintainability index of an application. Untestable applications hardly can stay well maintainable in the long term. After that, we talked about which problems can be solved by applying the MVVM pattern. Then we've seen what MVVM is in essence, of which building blocks it is comprised of. We determined the responsibilities of that building blocks. In a separate lecture, we took a brief look at services and their role in the MVVM pattern. We found out that services are usually required as input to view models. Thus, they can be easily injected either in the regular application runtime or during the execution of unit tests, where they can be mocked out. If you are not acquainted with the concept of mocks, I would suggest you to read a book about unit testing. Great! Let's get to the next module.